Okay, here's your practical investigation for the C5 topic. This is appendix page 6, investigating energy changes in reactions. So there are 5 experiments to do, and we're going to take you through each one at a time. The purpose of each experiment is to remember record the start temperature of the reaction, then the end temperature, which I'll provide for you now, and then your job will be to calculate the temperature difference and decide if the reaction is endothermic or exothermic. So the first reaction is to do with hydrochloric acid. So I've got some hydrochloric acid here inside this bottle, and I've already pre-measured 1 centimetre cubed into a test tube. We're then going to take the temperature using this temperature probe. So I'm going to leave this in here for a few seconds just to get used to the temperature, and we can record that down in the first box in our sheet. We're going to be adding some sodium hydroxide to this reaction. So here's sodium hydroxide. We're going to add the same volume, about 1 centimetre cubed, and when the substances react, we're going to be measuring the temperature difference, or the temperature, or the new temperature to say. You're then going to work out the temperature difference. So let's put our start temperature down, which is 22.3. I don't need to write degrees Celsius because I already have that written in the box. So 22.3. Let's add our sodium hydroxide. We're going to add another centimetre cubed, so we're going to double the volume. There we go. I don't need to be sort of too precise in my measurements. I'm not trying to make anything this time, just measure the difference in the reaction. Let's turn that back on. And let's record down the end temperature, which is now 26. So we've got an increase. Hopefully you've figured out what kind of reaction is going on here. And we'll leave it for another second and take our reading. So we get 27.1. Okay, reaction number 1 done. Your job is to calculate the temperature difference and decide if it's endothermic or exothermic. Reaction number 2, we've got hydrochloric acid again. So hopefully this time we've got another start temperature of around about 22.3 degrees. Let's just wait for this to change and settle. And to this one we're going to be adding some sodium carbonate. So that's the white powder that we can see here, sodium carbonate. And we're going to be using a spatula just to take a scoop of this in. See if we can focus that. There we go, we've got some sodium carbonate powder, and we're going to be adding a spatula of this in to our reaction. Okay. Right, let's take our measurement, which is 22.6 in this case. Let's add in our sodium carbonate. And because this is a carbonate, we should get some fizzing. So I'll try and show you that reaction as it's happening. Let's place our spatula in. And we've got some fizzing. Hopefully you can kind of see that happening now. You can see all of the bubbles there just appearing. Quite a quick reaction. Let's measure our temperature change. So the end temperature for this one will stop in a few seconds. 21.1 it is. Okay, let's clean that up and we'll go for reaction number 3. Okay, reaction number 3. This time we've got some ethanoic acid already measured out. So I'll show you, this is our ethanoic acid. We're now going to be adding our ammonium carbonate to that. So I'll show you what ammonium carbonate looks like. Again, we've just got another white powder here. And we're going to be adding a spatula of this. Let's take our measurement. Turn our sensor back on. 22.3. They should all be around that. They're all sitting in the same room at the same temperature. Ammonium carbonate goes in. And again, we've got a carbonate, so we should get a similar reaction happening. Okay, in it goes, and we've got some fizzing, which hopefully you can hear. Okay, we can see lots and lots of bubbles. It's a carbonate, so we should be getting some carbon dioxide there. Let's try and have a look at our temperature on our sensor. 17.1, 16.9 and so on. And hopefully you've worked out the temperature differences already and decided if these reactions are exothermic or endothermic. 16.1. That's fine for now. Right, on to experiment number 4. Clean this up. Okay, we've pre-measured some distilled water. So this is just basically pure water, just H2O molecules. Nothing else in there. 1 centimetre cubed already measured in the test tube. And to this one we're going to be adding some ammonium chloride. Ammonium chloride, similar to the other carbonates, there's a white powder. We're going to be taking a spatula of this, placing it into the test tube and measuring the temperature change. Let's take our initial temperature by placing this into our distilled water. It takes a moment or two just to settle and give an accurate reading. Now we could try and improve the accuracy of this experiment, but by using a temperature sensor that goes to an extra decimal place, if we were to do that, we would have a much more accurate measurement of our temperature change. So accuracy is to do with the number of decimal places that you can read to. 22.1 is fine. If we wanted to change or improve the precision of our results, then we would take lots and lots and lots of measurements, and we would try and compare any differences in our measurements. And the closer our results are together, the more precise our data is. All right, let's get this ready, up and running. So we're going to be taking some ammonium chloride now. Let's smash through this into our reaction, into our distilled water, give it a bit of a mix, and give it a moment before we take our reading. Right, round about 19 something. Let's have a quick look. 19 point. Give it a few seconds. We'll leave it at 1. Oh, 2. We'll leave it at 2. There we go. 19.2 degrees Celsius. Okay, final reaction now. This time again, we've taken some hydrochloric acid, but we're going to be reacting it with some magnesium ribbon. Let's place it in the wrong one there. So we've got some pieces of magnesium ribbon. These are just little pieces of magnesium being cut up into strips. We're going to take a few of these and place them into our hydrochloric acid. Let's take our initial reading. So we've got 22.0 now. So there are some slight variations between these. I think that changed as soon as I wrote that down. Let's take in a couple of pieces into the test tube. Down they go. So again, you can hear some fizzing. And you can see we've got some bubbles being produced as well. Sorry if that's out of focus. There we go. Let's have a look at the numbers. So we have got an increase here. This one's going to keep going for quite a bit. So we'll get to a point and we'll just cut off the numbers for now. We just want to identify the temperature difference and if it's endothermic and exothermic. So I'll take my measurement at now 37.9. That'll do. Right, that's going to keep going for a little bit. So what we've done so far then, we've done 5 different experiments. We've measured the start temperature and the end temperature. What you can do now is measure the temperature difference by working out the difference between the two numbers, work out if it's positive or negative, and decide if the reaction is endothermic and exothermic.